Okay, so here's the first derivation that we're going to try to do. And this is the basic one where we simply have a spring being acted on by the force F equals negative kx from Hooke's law. And we need to show that x equals c1 cosine omega t plus c2 sine omega t is in fact a solution. So remember when we go to do this that F is the same as ma. So we can write that, and we know that a is the second derivative of x with respect to time. So we can write this. And in this case, I would not set it equal to 0. I would just leave it like that. And then what we need to do is show, over here we know what x is, but let's find what x dot and x double dot are in the right-hand column. So x dot would be velocity. So that would be a derivative of cosine is negative sine, but we chain roll it and we get negative omega c1 sine omega t. And then we do the same thing with c2 sine omega t, and we end up with omega c2 cosine omega t. So notice how the sines and cosine flip-flop, and notice the chain roll. Then we'll take a second derivative of this. Negative sine becomes negative cosine, but the chain rule gives me an extra factor of omega. Whoops, and then we erase that. Derivative of cosine is a negative sine, so we end up with minus omega c2 sine omega t. And the chain rule says we need to draw out another factor of omega. So now let's substitute on the left, and we can say that m times everything we had for second derivative of x with respect to time, which would be the acceleration. All right, minus omega squared c2 sine omega t needs to equal negative k times x. Oh, but x, whoops, let me fill in for x. Actually, I better give myself a little more space here. So I'm going to write it down here, equals negative k times x, which was c1 cosine omega t plus c2 sine omega t. Now you'll notice both sides are very similar. If I write, copy down negative m omega squared, bring out the omega squared, or negative omega squared, and we're left with c1 cosine omega t plus c2 sine omega t on the left-hand side. And we can leave the negative k, and we have c1 cosine omega t plus c2 sine omega t. All right, and therefore, if you look at what's the same, the entire parenthetical quantity will divide out. And so that means that, give myself a little room here, negative m omega squared better equal negative k. All right, or if you prefer, that gives us that omega squared equals k over m. And I put the omega naught on there because this is with the no damping. And so we can, in fact, which since there was no damping, all of the omegas equal omega naught. All right. So because omega naught would have to equal, that would be omega naught squared, would need to equal k over m. We can see up on our little sheet for our practice test here that in fact was the first statement that we said is true. So as long as we define omega that way, we have now proven this, okay? So we have shown, in fact, that c1 cosine omega t plus c2 cosine or sine omega t is the solution to f equals negative kx.